Hello everyone, my name is Nate Ferguson and this is Yeast Basics 2, Module 2, Lecture 2. Let's get to it. So today's problem. Many brewers have problems harvesting yeast, especially for sequential batches and especially for New England IPAs. This can result in increased yeast costs, decreased yeast health, and most importantly, an unavailability of yeast cells. So today, we're going to be exploring how to harvest yeast cells from tanks, when you should harvest yeast cells for optimal yeast, beer and yeast quality. So with that, let's get into it. Now, before we begin, I need to make a correction, more of an update, if you will. Now, back in February 2019, I released a blog post titled A Practical Guide to Yeast Repitching. Now, since posting that blog, I have found a handful of new information that has changed the way which I look at this topic and has changed what I normally recommend. So you may be asking yourself, what do I want to change? One thing in particular, this layers diagram, which you see on the right-hand side. Now, this diagram is not technically wrong, but for most craft breweries, it is functionally irrelevant. Now, this study was done using 1,000 hectoliter fermenters making lager beer, using what I'm going to argue today is a poor method for cropping. This image is not wrong, but it's just not useful. So I hope to explain to you today why this is and to give you better solutions for this problem. Now, this change comes from a different approach to cropping and harvesting. The biggest difference between the blog post we posted in 2019 and today is the approach. So everything I mentioned in that article is correct. There are just better ways that we can solve this problem and get ahead of them before these problems occur. So you may be asking, where did I find this information? How did I pull these things out of the ether? Well, it's simple. I started looking back. I looked back in time and looked at some old brewing textbooks, some things that hadn't quite made their way into the North American craft brewers' knowledge base. What's old is new again, and that's what we're going to be looking over today. This in conjunction with some new resources for NEIPAs. So the TLDR, the too long didn't read for today's lecture. Bottom cropping early is better. Crop 48 hours into ferment or as soon as FG is reached. This is going to make your harvesting your yeast cells much easier. Cropping after cold crashing is too long. Leaving yeast in contact with the beer is a bad idea. This is going to expose you to many potential negative flavor compounds and things that are going to hurt the quality of your beer, so don't do it. Time and temperature will vary depending on tank and brewery. You need to play around with this. You're not going to find a single solution that's going to work for you versus the brewery down the street versus the brewery out of your city. You're going to have to play around with this a little bit. And regardless of time, transfer the yeast slowly to avoid tunneling. We'll talk about what tunneling is quite soon. So lecture breakdown today, we're going to talk about the types of cropping, mainly focusing on bottom cropping and centrifuges. We're going to talk about when to crop. We're going to talk about when or why not to do it post cold crash. And then we're going to go through a lot of different questions today. So with that, we'll jump in. Now, the disclaimer, as always, the goal of this series is to educate and advise you on the application of yeast within the brewery to avoid common yeast problems. Now, I will break down topics into simpler basic components, and this will sometimes mean that I oversimplify or glance over details in an effort to reinforce the main points. If you want us to go into more detail, put your question in the comment section down below. And a little bit of a word before we begin. Out of all the lectures I've done online and things like that, I expect there to be the most pushback on this one. This isn't because it's revolutionary or heretical. It just goes against what most breweries' SOPs are. Some people are probably going to say that this content we talk about today is wrong. I'm going to ask you to push your prior knowledge and experience on this topic aside and hear me out, please. You may make your life a lot easier. So with that, we'll get into what bottom cropping is. Bottom cropping is just the removal of removing yeast cells from the bottom of a tank, normally a CCV or a conical, also known as a conical fermenter. Now, it's a very simple process. All you do is open the bottom port. The yeast will then drain out. You collect that into a yeast brink. The details for this will become muddy, and we're going to start breaking these things down. We're going to start with why yeast cells do this to begin with. Why do they flocculate and how? So, yeast cells flocculate when the yeast cells are near the end of fermentation, and they do this by producing two compounds. The first one is a protein known as Flo1, which is a binding protein. The second one is a mannan protein, which is the site in which Flo1 binds onto. These two bound together, enlarge the average size of the cell, increase the density, and these two, through the phenomenon that we call Stokes' law, increase the rate of sedimentation. Now, flocculation will become more complete as fermentation progresses. As we near the end of fermentation, all of the cells will bound together and precipitated much more tightly and efficiently to the bottom of the tank. Now this can actually have some problems for it, which we're going to address right now. So we're going to talk about the kind of common method that you see in most breweries in North America in my experience and how I was taught to crop yeast operate. So in a normal North American yeast cropping occurs as below. The beer reaches FG, or final gravity. The VDK test, forced diacetyl test, is cleared, and then cooling is applied. Then roughly 24 or even sometimes 96 plus hours after, the yeast cells are cropped. Now this is a standard method that we have a handful of breweries that use. I used this for the longest time. We can make this better. We can improve this. And that's what we're going to talk about mainly today. So there's a few issues here. One of the biggest issues you see with cropping is what we call tunneling. This is the diagram on the right-hand side we saw before that I wanted to edit, but it's a great image here. This is what tunneling is. When the yeast cake sticks to the sides of the tank, we get a tunnel that forms throughout that yeast cake, resulting in beer flowing out instead of the yeast. Now, this primarily occurs due to over-flocculation or complete flocculation. The cells are bound so tightly together that they almost form a sticky, putty-like substance, which means that you open that tank and they are adhered to the sides of that tank. You're not going to get them out. This is not great. These cells are what we want to be working with in the next beer. If they're stuck due to over-flocculation, then they're kind of adhered to the side of the tank, we're not going to have access to them. Not ideal. Now, how do you overcome tunneling? Now, there's a few options here. We can harvest earlier. If the less time the cells are inside the tank, the less compact they become, the less putty-like or less sticky they become. The chance of them being stuck to the sides of the tank is reduced. So if we harvest earlier, this will allow those yeast cells to more evenly flow out of the tank. Now, on the same line, if we harvest before cooling is applied, cooling typically causes a compaction. That tightness of the yeast cells becomes even more so. They become even less sticky or even more putty-like. Less cooling is going to mean our chance of tunneling is going to decrease. These two elements and this avoidance of tunneling is going to form a large portion of the basis of what we're talking about today. Now, bottom cropping issues also come up when we start looking at New England IPAs. The issue here is that most of these beer recipes have a lot of hops that are added midway through fermentation. This means if you use common methods for cropping, which means the beer's gone through fermentation, it's been cold crashed, and then we crop our yeast, that dry hop is still within the tank, which means when we're cropping our yeast cells, we are getting a mixture of hops and yeast. This is not a good thing. Alpha acids and hops in general will degrade yeast cells. So by having the yeast cells in high contact with these hops, we're going to get a poorer quality, lower quality yeast culture out of that tank. Now, this coupled with the high to moderate flocculation we see of most New England IPA strains means that we're in for a bad time. We have yeast cells that are very sticky and adhere to the sides of this tank and their lower viability due to the dry hops, making managing the yeast from a NEIPA brewery very difficult. So how can we improve this? There are some easy ways. Now, what I want to highlight here is this image. This is the image I showed last lecture from from Goose Island Brewing. And one thing I want to highlight here is you'll see that around the 48 to 72 hour point, they actually crop 50% of their yeast. You may be thinking this to be quite odd. Why are they cropping their yeast before FG is even reached? Why are they cropping their yeast before fermentation has finished? And why 48 hours in? There's actually some good reasons to this. The first one here is that they're actually cropping their yeast before they've added a dry hop. This means that when they're cropping this yeast cells, these are going to be higher quality yeast cells simply because they don't have the antifungal properties of the hops present. This can be a good thing. We're going to talk about other attributes of this going forward. You'll also notice that they'll dump additional yeast when they do their second dry hop, and they'll remove their hops and yeast later on into the process as well. You'll also notice that they say dump hops each day after second hop dose. They're constantly dumping yeast out of this tank every single day. This is a good idea, and we're going to be explaining today why this is. Now, there are a handful of benefits to harvesting early. Now, examples like Goose Island show that this can be done. Now, the benefit here is decreased time between yeast pitches. If I'm harvesting 48 hours after I inoculate my beer, that means that I can take those cultures and reuse them right away. I can, inoculate a brew on Monday, and then on Wednesday I can harvest those cells and use them again for a separate brew, and then theoretically harvest them again on Friday and use them again. This is far faster than what is kind of standard practice in most breweries. No hops are present in the yeast culture, so if we're making NEIPAs or anything that's a modern hop-forward beer, we're going to have a higher quality yeast culture. And based on that, we're going to have increased viability. This is due to lack of hops, but also a decreased time in tank, lower concentrations of alcohol in the environment, higher nutrient concentrations. Overall, we're going to have healthier cells. Now, the first time I saw this data, I thought, okay, this is kind of weird. Is this just a weird thing that this brewery happens to be doing, or does this actually make sense? It actually makes sense. So, there have been a handful of studies that have been done. What the data you see here is from a paper that was published in 1999. This is not new. This is information that people overlooked, especially in North American style brewing. So in this, they looked at a few different methods. They looked at either one of two: harvesting halfway or 3/4 of the way through fermentation, so while active ferment was still occurring, or harvesting right as FG had been achieved, so before cooling was applied. In both conditions, this is what they found. Overall, the cells that were cropped midway through fermentation or as soon as FG hit had a higher viability. They also were larger, which typically is a sign that these yeast cells are healthier. But that's not all. They also performed better, these cells that were harvested earlier into fermentation, or right as FG was achieved. These cells hit final gravity in the subsequent brews faster than the normal harvested method. The normal harvesting method here being cold crash and then harvest. They exited the fermenter faster. The viability of these cultures was higher post-fermentation, and they cleared the diacetyl test, the VDK test, sooner. Everything here indicates that harvesting these yeast cells midway through fermentation or as soon as FG is reached is going to produce a higher quality fermentation and a higher quality yeast culture. This is great, so why aren't we doing this? Now, cropping cells early seems to have a lot of merit. Now, speaking with some clients, and there's a lot of anecdotal evidence too, a handful of our clients have started to do this with a great impact. So what's the downside? Well, the first off is that change is kind of hard. People like to do the thing that's currently working, and I am a proponent that if it ain't broken, don't fix it. The other thing here is that the slurry is thinner. Now, this can be a good thing, especially for culture, for very thick cultures. Culture density can be a problem. Now, most of us are likely used to working with very thick slurries, especially when we work with English ale strains or things like that. Now, it's common practice that a good slurry is between 30 and 55% solids. You can see on the image on the right-hand side here what that means. To give you an example of what's on the right-hand side, say 100 mils of the culture is put into a tube. You let it sit for a day or two, and you see at what milliliter that culture fractions out. So if you add 100 mils and you see that after a few days only 30 mils is contained of yeast, that's roughly a 30% solids culture. It's going to be very done with a graduated cylinder or anything like that you have around the brewery. Now, a lower percent solids culture is actually easier to work with. It's easier to flow. It's easier to push from tank to tank. If we have a brink that is full of essentially a putty, it's almost impossible to move that culture around. It's also very difficult to get cell counts or any sort of information on it to do analysis. Believe me, we do a lot of it. We know it's difficult. Also, if we're harvesting early and we have cells that are less compact, we're less likely to get tunneling. Remember, tunneling is all based on how tightly those cells are attached to each other, how much they've flocculated to each other, and how much they've stuck to the sides of the tank. If our yeast cells are more fluid, they haven't precipitated or they haven't flocculated as tightly, they're less compact, we are less likely to have tunneling, which means we're going to have easier harvests on these tanks. Now, you still need to go slow, but this is going to make your life easier. You're probably harvesting a bit more of a volume standpoint of the culture, but it's going to be easier to work with. Now, there's other benefits to cropping early. This is an image we showed in, I believe, Lecture 2 of Module 1 when we talk about glycogen and sterile content. And you'll notice that Goose Island and other breweries like it are recommending the harvesting the first pitch around 48 to 72 hours. And from what we saw in that data set before, we're roughly in the period of peak glycogen. This is great. Glycogen is the nutrient reserve that these yeast cells are using in order to keep themselves alive during storage. We want the cells to have the highest glycogen content. Now, if we were to, say, go through a normal cold crash system where we, let the beer finish fermentation, we're probably at 120 hours, maybe 160 hours. We then let the beer cold crash go to 200 hours. We are seeing a consistent decrease in our glycogen concentration. This isn't great. We want our yeast cells to have as much nutrients available to them as possible. Harvesting earlier is going to provide more nutrients. The yeast cells are going to have a higher amount of nutrient reserves present within them. This is great. Now, we've also seen this in other studies. Both these images here show that as we store our culture for a longer period of time, whether it's aerobic or anaerobic, we see the glycogen concentration decrease. You want to use your yeast cells as soon as possible. This is a standard no matter what, whether you use the old school post-cold crash harvesting method or this newer approach. More glycogen is going to equal a longer shelf life. So if I can get those yeast cells out of that tank faster, my yeast brink is going to be able to stay around for a longer period of time because it started off with more glycogen. So that's the argument for cropping early. Now, what about a centrifuge? A centrifuge is also a very common method you see breweries use. Now, centrifuges apply a large amount of force to the cells, which induces settling. I mentioned Stokes' law before. This increases the gravity fraction of that. That's beyond the lecture today. But the issue here is that these cells will get damaged. So on the top right, you see here is a yeast culture with a scanning electron microscope pre-centrifugation. And on the bottom, image B, you see a culture post-centrifugation. You notice that the one on the bottom right looks damaged. And it is. Centrifuges will apply a lot of damage, a lot of stress onto these yeast cells. Now, some cell lines can handle the stress very well. They're not, they can deal with it. They can tolerate it almost no problem. Other cell lines are completely obliterated with a centrifuge. This is not something that's meant for everyone. Certain cell lines work better than others. It's not something that's usually recommended or not usually the standard. But for some breweries, it works great. So with that, we're going to go through some kind of basic questions in regards to harvesting. So question 1, when should I crop my yeast? Now, in the past, I would have said, this is based on that blog post from 2019, I would have said post-cold crash. My answer has changed. Now, as soon as possible. And this is for a few reasons outside of what we've already talked about. Now, as yeast cells sediment, they will begin to throw off low molecular weight proteins, which will damage the head retention. These can be some autolytic byproducts. They can actually be some nucleic acids, a whole bunch of stuff. These are going to hurt the head retention of that beer. Your beer is not going to look as good if you have yeast cells present for a long period of time. Now, if the cells are stressed, they're also going to secrete an enzyme known as proteinase A, which breaks down all the foam-positive proteins. Cells in suspension don't really do this. So if we had Hefeweizen yeast or things like that, they don't really do this. But sedimented cells do, and they do produce more of this. So it's not a good idea to have this. And stressed cells typically result in autolysis, which then will increase the pH of the beer, which for most light lager beers or crisper, lighter beers will hurt drinkability. Not great. These are all reasons for us to get our yeast off of that beer as soon as possible. Even if you're not trying to harvest that yeast cells, get your yeast cells off the beer. So question 2, does tank size impact how harvesting works? Now, larger tanks do pose some issues, mainly due to CO2. Larger tanks, especially ones that are 10 meters tall or so, will place roughly 15 psi or 1 bar of partial pressure of CO2 gas pressure on the cells. This means that when we're harvesting the yeast cells off the tank, those yeast cells are essentially carbonated, just like the beer. So when we then transfer our yeast cells from the tank into a brink, they're going to be foamy because the brink typically is not pressurized with 15 psi. Therefore, we're going to see a lot of foam inside that yeast culture. Not only this, as those yeast cells respond from a 15 psi high CO2 environment to a non-15 psi CO2 low pressure environment, that's going to cause a lot of internal pH stress and just a little bit of shear stress as well, which will decrease viability. So a solution here, harvest early. Cells are not or less dormant earlier in the process. This means they're going to be able to respond to the stressors more easily and adapt to the pressure changes more rapidly. Additionally, because they haven't been at the bottom of the tank for as long, they will typically not have dissolved as much CO2. And for us in this topic, that's a good thing. Question 3, should I dump yeast at cold crash? This is likely a good idea. As we mentioned for question 1, removing the yeast to any beer during cold crashing reduces the chance of autolysis, reduces the chance of low molecular weight proteins being secreted, reduces the chance of proteinase A activation. These are all good things. Should you dump your yeast cells at cold crash? I probably would. Now, you can collect these yeast cells for repitching, absolutely. I don't see a negative side to this as long as you can control your DO pickup. I think this is a great idea. So question 4, if I crop yeast with cementable wort, is that okay? Now, absolutely, and this is going to take a little explaining because it might actually be the ideal situation. So to give you the context for this, if we are to harvest our yeast cells 48 hours into fermentation, roughly 4 to 8 degrees Plato based in the beer before FG, we have some fermentability left. We have some sugars that those yeast cells are going to consume, and we now have a concentrated yeast solution with a little bit of sugar. This might sound like an odd idea, but if you look back into some brewing textbook and see what was classically done, this was pretty standard commercial brewing practice. A lot of brewers, when they're trying to keep their yeast cells alive for 3 to 4 weeks, or even if it was just a week, they would often feed their yeast cells. They would give them some fresh wort to keep them alive and going. By harvesting your yeast cells early, you're functionally doing the same thing. You are keeping yeast cells alive and fed, especially if you're trying to keep them alive for a 3 to 4 week period between brews. You can push this a bit further, but I wouldn't want to. Now, a few bits for this. Make sure your culture's cold. Otherwise, those yeast cells will rapidly ferment and cause a huge mess. So keep them cold as much as possible. And also make sure that device is vented. If you're using a bucket, it's easy. Don't put the lid on super tight. If you're using a brink, cool. Just make sure you have some way to vent that CO2. Otherwise, you will create a pressurized vessel. We don't want to create a bomb. But this is likely a really good idea. Will cropping leave more diacetyls? This question makes a lot of sense. No, the cells in the bottom of the tank that have already completed fermentation have no relation with the cells that are going to be helping to reuptake diacetyl. Only cells in suspension will contribute to diacetyl reuptake. If you do find issues with diacetyl, I'd recommend you first look at your aeration and pitch rates. That's usually where to go. So based on this, crop away. Remove those yeast cells. They weren't going to help you with your diacetyl cleanup anyway. You can crop those and use them in the next batch, no problem. Question 6. I'm happy with my yeast cropping method. Awesome. Don't change it. If it ain't broke, don't fix it. However, if you have a tank where you know the cells aren't going to be needed, I'd recommend you try this out. It might make your life a lot easier in the future. Go for it. Have fun. And question 7. I'm having issues with flocculation in general. I can't get these yeast cells out of the tank already. I rely on that cold crash in order to condense these yeast cells out so I get proper culture density. We've had a handful of clients have this problem. We found a solution. A lot of brewers are lacking magnesium. Might sound a little bit silly. Hear me out. Most of the enzymes associated with flocculation, those flow-1 and manoproteins, they're all calcium dependent, but they also require some magnesium. This is often overlooked. The importance of magnesium inside of your wort is very overlooked. Everyone focuses on calcium. Add some magnesium to your wort, you will likely see an increase in flocculation. Any source of magnesium will do. Just add some magnesium. It'll help you out with flocculation. If it doesn't, reach out to us further. We can help you out further. Now, with those questions answered, this lecture is already long. I had to cut a bunch of stuff today as well. I was going to go into some yeast brinks and do some more content on that, which we are still going to do. Might be a bonus lecture, some of that at the end. Expect to see more content on yeast brinks in the future. But based on that, I'm going to answer some quick rapid fire questions that we often get from some clients. So here we go. Where should I store the yeast cells in? So the question here essentially, what can I use as a yeast brink? Use what you have access to. Many large breweries use buckets. There's a very large brewery in our area that uses 50-liter corny kegs for all their yeast management. Actually, I know 2 of them now I say that come to mind. We're going to talk about this later. There is no right or wrong device to use for a yeast brink. They all have pros and cons. Question 2, should I aerate my wort or should I aerate my yeast? You can do either. The goal of wort aeration is to get oxygen to your yeast cells, not to your wort. So you can aerate your yeast directly. Now, in my experience, aerating your yeast is a bit more mechanically complicated. You're trying to get to a super high dissolved oxygen concentration with the yeast, which isn't always achievable. Aerating your wort is functionally typically easier. The only exception to this is home brewing. If you have the ability to, say, make a quick little starter 12 to 36 hours before you're brewing for home, and put it on a stir plate, you're essentially aerating your wort by aerating your yeast before you pitch it. Makes your life a lot easier. Question 3, should I store my yeast under pressure, and can I store my yeast in the cone of a fermenter? I'd recommend no. This puts a lot of stress on your yeast cells. Yeast cells with CO2 pressure, it is a physical force. It's mechanical force pushing down. It will put additional force and pressure on those yeast cells, so I don't recommend it. Same thing goes for the fermenter. In the fermenter, not only do you have the pressure of CO2 if you were to pressurize, but you also have the low nutrient environment, the high alcohol content. It's really not a good place for your yeast cells to be. So I wouldn't recommend it. There are breweries that do it. but it's not what I would typically recommend. And from my experience, the breweries that do it have either found mechanical ways to overcome this, or they have more problems. So with that, we covered a lot of content today. I hope you guys learned something. Thanks for spending some time with us today, going over Yeast Basics 2, and we'll see you soon. Cheers.